Hello everyone. Today we are going to talk about function. So before we talk about function, I want to talk about quantifier. Okay. So we are going to have a much more detailed lecture about quantifier and predicate. But for function also we are going to use few symbols. So we want to be familiar with before that. So quantifier means some symbols by which we can quantify. Okay. So for the discussion of function, we'll just learn about two basic symbol, two basic quantifier, this one and this one. Okay. So this quantifier, we write it like that, like a reverse A. Okay. It means that for all or for every. So it will be read as for all or for every. So for whenever we are going to use this symbol and then we are going to use a variable, it will be read as for all x. Okay. So for all x or for every x. So let's see the examples. Here we are saying that the so for all x and y belongs to the real number. Okay, for all x and y belongs to the real number, we have x square plus y square greater than 0. So we are saying that for every x and y that belongs to the real number, we have x square plus y square greater than 0. Obviously we can verify the truth because square value of any value is going to give you a positive number. Alright, so if we add them, that will be greater than or equal to 0. Okay, so whatever the value of x and y is, their summation of square will be greater than or equal to 0. So we can say, using mathematical notation, using quantifier notation, we can write it like that: for every x and y, or we can also say that for all x and y that belongs to real number, we have x square plus y square greater than or equal to 0. All right. So whenever you will see this quantifier symbol, it means that for all, okay, or for every. All right, you can write one variable or you can write two variable for all x and y, like that. Okay. Another quantifier we'll know about, there exist. Okay. So there exist. So this symbol, it means that there exist. So some polynomials have no real zeros. So there exist means if there exists a value, okay, then we are going to use this quantifier. So we are saying that some polynomials have non-real zero, some polynomials have no non-real zeros. Okay, so we are saying that there exists a polynomial. It means that if there exists at least something where we can use this quantifier. So it means that exists a polynomial p of x such that for all r belongs to r, we have p of r not equals to 0. Okay, so just remember this one means for all. Okay, so for all x, and there exist means there exist ax. Okay, if there exists ax for which some condition, some predicate value is true, we are going to use there exist quantifier. Okay, so in the discussion of function, we are going to see a couple of more example where we will use for all and there exist quantifier, and it will be much more clear how we are using them. All right, so let's talk about function. So what is a function? A function means actually whenever we are talking about function, a function means like in real world, a function means like a task, a job. So let's say you have a pen. Okay. So you have a pen, I can ask you what's the job of this pen? What is the function of this pen? Okay, you don't know anything about a pen, and you are asking what is the function of this pen, and I may say is that this function, this is the pen, its function is that it can write. Okay, now in mathematical term, a function means it's a specific purpose that takes a input and that produces a output. Okay, for example, I'm saying that I have a function that calculates the square value. Okay, so I will give x a input x, and that will return square of x. Okay, all right. So let's see, I'm going to provide, I have a function that returns the absolute value. So I'll return a any value, and that is going to give you the absolute value, the abs of x. Okay, so if I give -1, that will give you only 1. If I give +1, that will also give you 1. So a function, what is a function in real world? A function means it's a job that will take an input and that will return an output. Okay, now we are going to see the purpose of function, the definition of function, few mathematical terms about function uh, in the perspective of discrete structure. Okay, so a function, let's see, we have to set a and b. Okay, then a function f is a function that will form, a function is a form a to b if satisfies the following constraint. For every a belongs to a, okay, we have to set here, let's see, 1 2 3, and we have here 2 4 and 6. Okay, for every a belongs to a, there is exactly one b belongs to b. Okay, such that ab belongs to f. So f is going to be a set of ordered pairs. Okay, f is the function, f is a set of ordered pairs where the first element means where the first element will come from a and the second element will come from b, and we are saying that for every a belongs to a, there is exactly one b belongs to b, such that ab belongs to f. All right, and function f forms a binary relation from a to b. So function f actually forms a binary relation from a to b. So let me write down what the format of f is going to look like. Let's see, I have f looks like this. Now let's find out whether this is a function or not. For every a belongs to a, okay, there is exactly one b that belongs to b. Okay, that belongs to b. Okay, such that ab belongs to f. All right, for every a I have 1 2 3. So for every a I have actually a ordered pair for every a of, for every elements of set a. So I have ordered pairs for 1 2 and 3. Okay, and there belongs there exactly one b for every a. Okay, I have 2 for 1, I have 4 for 2, I have 6 for 3. Okay, all right, and these second elements of this ordered pair belongs to b. Now function f forms a binary relation from a to b. Now one important thing about is that if we have a mapping like that, ab belongs to f, we can say that f of a equals to b. A function actually what it does, it maps every element of a to an element of b. Okay, so you can see that it maps every element from a to an element from b. All right, so we can in the function definition, using the function definition perspective, we can say that function of a equals to b. So it's a function where the function will take a input, okay, take a variable a, and it will produce the output b. Okay, so that's our set of a and that's our set of b. All right, so we have to have every element from A. Okay, and every element of A is going to map exactly one element from B. Okay, so informally a function f maps the element of an input set A to the elements of output set B. So again I am talking about using the term as a input and output. So a function means we write it like that, or you can think about it like that. That's a f, that's our input, it will produce B. Okay, so function takes input A and it will produce B. So a function f maps the element of an input set A to the elements of input set B. Okay, more formally we write it like that. F is a function, A is a input set, okay, is the input set, and B is the output set. It represents that f is a function from set A to set B. Okay, that is going to associate an element fa, that the result of fa has to belongs to our set B. Okay, and A belongs to the input set A. So in this example you can see that this is our input set A, this is our input set B. Now we have to have every element of A, okay, every element of A in our ordered pairs of F. Okay, so there has to be an output for every element of A. Okay, and the output has to belong in the set B. So the domain input of F is A and the output of F is B. All right, for every input there is exactly one output. That's important. For every input there is exactly one output. I cannot write it like that. Let's see, I have one element here in A. So this input, if that's the mapping is by F, using this function I cannot have more than one output from one element. Okay, for every input there is going to be exactly one output. So let's see, each function has exactly two key points. It's very important. We have to understand whether it's a function or not. We have to understand the two key points of a function. Every A in A must be the first coordinate of an ordered pair in the function. Okay, each element of A must be the first coordinate of exactly one ordered pairs. Okay, every A in A must be the first coordinate of an ordered pairs in the function, and each element of A must be the first coordinate of exactly one ordered pairs. It is this condition is saying that each element in A will have exactly one output. All right, and this condition, and the condition 1 is saying that every A has an output. Okay, so this is the two key points. Informally you can remember that every A, okay, every A will have an output, every A will have an output, and every A will have exactly one output. Okay, so let's see an example. I have a set A 1 2 3 and B x and y. Okay, so we are saying we are going to find a function which will map A to B. Okay, so that means that's my input set and that's my output set. Okay, so if we draw the figure it will look like that. So 1 2 3, that's our A, and x and y, that's our B. Okay, so the first one, 1x 2y 3x, is it a function? So let's draw that. 1x 2y 3x. So let's try to figure out whether that's a function or not. So for number 1, every A has an output. So you can see that Here, in the first, when we are listing all the ordered pairs of A, every elements of A is actually present there. We have 1, 2 and 3, right? So the first condition is done. What about the second condition? Second condition says that every input is going to have exactly one output. Means each element of A must be the first coordinate of exactly one ordered pairs. Okay, so every element will have exactly one output. So you can see that 1 has X and there is no ordered pairs with 1. Okay, 1 has only one output X, 2 has one output Y, 3 has one output X. Alright, so 2 is also done, it's a function. So the first example F, it's a function. What about the second one? So let's try to use a eraser. Okay, so that's my X, that's my A. Okay, so from this function, from the second example, I can see that I have a mapping from 1 to X and I have a mapping from 3 to Y. Okay, but 2 is not present there. So this one is not satisfying condition 1. So I do not have a mapping for the element, for one element of A. Okay, so that's not satisfying condition 1. So if it doesn't satisfying at least one condition, we can say that that's not a function. For every element in the input set, we have to have an output. Okay, that's our condition 1. So let's look at the second one, the third one. Okay, so the third one is saying, let's do the mapping. 1 to X, 2 to X, 2 to Y, 3 to Y, and we are saying that that's not a function. Why is that? There we have every element from input set. We have 1, 2 and 3. Okay, but what about the condition 2? Every element of A must be the first coordinate of exactly one ordered pairs. Exactly one ordered pairs. That means we have to have exactly one output. But here seems like 2 has 2 output. The element 2 has, we have one element 2 that is mapping to more than one output, 2 output. Okay, so f of 2 we have X and Y, but that's not possible. Okay, as a function that's not possible. Function means actually every input there is exactly one output. Every input there is exactly one output. Okay, so this one is not a function. Okay, the function notation, we have the very informal function notation f. We write that A to B, where A is the input set and B is the output set. So we say that f is a function from A to B. So that's how we can denote the function between sets. A and B both are the set. Now let's see, A has element like A1, A1, A2, A3, and B has elements from B1, B2, B3 like that. Okay, we can denote a function between elements. Okay, in that case we are going to use this symbol. It's actually an arrow symbol, but with this additionally we are going to use this one. Okay, so that will define the functions between elements. Okay, so it is going to actually denote the relation between like that, if A equals to B. Okay, so if I have something like that, A1, B1, okay, that means f of A1 equals to B1. So A2, B2, these are the elements of set. Okay, that means f of a2 is going to map to the value b2. Okay, so example, let's a and b, they both are a set of real number. Okay, and suppose we have a function f equals to ordered pairs. F is the set of ordered pairs where y equals to x square. Okay, so that means actually we have a function here, like if the input is a x, the output will be x square. Okay, that means y equals to x square. All right, so here we can write that f of x equals to x square for all x belongs to R. So we can see that we are using the quantifier. So the f of x value will be x square for all x belongs to R. Okay, and when we are going to do the mapping, all right, when we are going to do the mapping between elements, it will look like that. If the value, if the element is x, then this element will be x square. Okay, if the element is x, that will map to the element x square. Okay, so this f is going to actually look like 1 1 2 4 3 9 4 16, like that. Okay, because you can see that the first element is x and the second element is x square. Okay, first element is 2, second element is square of 2. All right, and that's we're talking about all real number. I'm showing you example only with all integer number, but it's actually talking about all the real numbers. Okay, so some definitions, when we have a function like that, f from a to b, that means a function from a to b, which a is a set and b is output set. So we say that, okay, so that's our a, that's our b, and mapping are from like that. Okay, now we say that a is the domain of a, means input of f is the domain of a, domain of function f is a. Okay, output is, we can say the output is the target of f is b. So here we have the function f, the domain is a, so this one is the domain, the set a is domain, the set b is target. Okay, and the range of function f is the range f equals to b belongs to b. Okay, there exists a that belongs to a with ab belongs to f. Okay, the range of f means actually the all the elements in b that belongs to b, but that elements of all the elements b, all right, from the b where there is actually a input a such that f of a equals to b. Okay, for example, let's see, I have 1 2 3, I have x, y and z. So let's see, 1 maps to x, 2 maps to x, okay, and 3 maps to y. Okay, now you can see that there is one element in b, z, for which I do not have any element in a such that f of a equals to b. Okay, I have such element z in b. Okay, for which for the element z I do not have any element in a. Okay, that will map the elements from set a to set b. Okay, so in that case the range is actually x and y. All right, so in the next segment I am going to talk about two different type of function, onto function and surjective function.